completion. One thing that's missing in this picture, you'll notice the carport. We really need to add a picture here. We need our plug-in electric vehicle. And this home also contains the Smart G appliances that we're coming out with next year, where these appliances will be pre-programmed, will be set up for wireless communication to receive information from the utility at the time of use rates, and these appliances will make decisions which can be overridden by the consumer or programmed by the consumer, but they'll make decisions to mitigate your energy usage. So you might have your freezer may defrost. Instead of defrosting in the middle of the day, it may decide based on the time of use, we're going to defrost between 1 a.m. and 2 a.m. and take advantage of low-cost power then. And the dishwasher, you might load it, turn it on, but it may not actually run to midnight or 1 o'clock when power is cheaper. It'll make those decisions for you, and there's a big debate there. So I think there's a lot of segmentation in society. I think some people want to be very proactive here and want to be very engaged in how they use energy. I think a lot of us are probably going to want to do a set and forget and have the technology do the work for us. You also notice there's a storage device in the basement of this facility, and maybe in the basement or maybe in the garage, an energy storage device also under consideration. But again, I think the jury's out there. I think the debate is, will we have home energy storage, or will we have our plug-in electric vehicles serving that dual purpose? And back to the net zero home, all this ties together. The goal would be, in a very exciting future, the home then becomes not only an energy consumer, but an energy generator. And so when power is dear during the afternoon hours and it's through the roof, and you've got some excess wind power going on and some excess solar going on at your home, you can sell that electricity back into the grid when it's dear, and then in the off-peak hours when power is cheap, you could buy some of it back and actually store it in your battery system. And so the idea is, on a net basis, your cost of energy should go to zero. And that's the theory, and that's what we're working on. The next one, I want to take you through a project in Maui that we're doing. Other than the fact that it's a nice place to visit, it does have very strategic reasons why we chose this to be a pilot. This has been worked on for about over a year by us. This is actually, I would maintain, probably one of the most challenging grids in the world. Maui is a very developed island, very heavy energy usage. They have to me, it's a microcosm of what the rest of the world is facing in the future. Maui has electricity rates that are 3 times the national average, so they're paying about 30 cents a kilowatt hour versus about 10 for the national average. Maui gets, which is very unusual, Maui gets about 90% of its electricity from oil-fired generation. And together with that oil-fired generation and with transportation sector, their cars, Maui exports about $7 billion in cash a year in the form of hydrocarbon payments. So what's exciting about Maui is Maui has an abundance and a great potential for wind and solar. The challenge is it's an island and it's a grid system. So unlike this area, or most places in the mainland, we're interconnected to other grids. Most of our utilities have some flexibility during peak demand or peak lulls, or lulls in the demand. They can move power to and from other utilities and on the grid, move it around. But on an island system, you don't have that flexibility. So that's why this became very interesting from us from a technology point of view. If you have this very high penetration rate that's going to take place in Hawaii, in fact, the Hawaii legislature has passed legislation that says by year 2030, they want to have 70% clean sources, not only for their utility sector, but for their transportation sector. And it makes a lot of sense here, especially for the plug-in electric vehicle, when you consider that an island system, these are usually short commutes. It's a perfectly nice fit for electric vehicles. And so they're looking to basically clean up both the power generation and the transportation sector. And so this is going to be a very dynamic grid. I was there actually 2 years ago, and the utility people were complaining at that point when they had a very low penetration rate what havoc these wind turbines were playing on their system. The wind, can be very, very volatile, very fluctuating, and it was causing their other dispatchable assets to always be ramping up and down to try to counteract the wind. And in fact, one of the things that's not well known here in the U.S. is, and this is one of the reasons that Pickens canceled his project on wind. Wind today in the United States is being curtailed. I mean, there's many examples where wind is blowing, power is available, it's free, it's green, basically free because once you curtail it, it's free. because the person who owns that wind farm has no place to park that wind, has no place to take it, so it's basically wasted generation. They basically disengage the generators and ramp down the windmills. And the reason for that is that there's too much congestion on the system, there's no place to send it. So that's on a big system, and on an island system, we certainly don't want to see that happen. So we want to integrate all of this. And again, what we would expect as we deploy our technologies, and we're looking at battery technology, we're looking at better forecasting of wind, we're looking at demand response. We want to see a very dynamic system in Maui, so as that solar and that wind is being very volatile, the demand side of the equation is being very counteractive to it and keeping it all in check and keeping it all fully utilized. So with that, this will become a showcase for us, and we will demonstrate this, that if it works here in an island system in a very productive way, whatever challenge we face anywhere else in the world, I would maintain would be a lesser challenge than what we have here in Maui.
Luke? How long has it been going on?
Over a year. We got about 2 more years to go. Yep. And with that, I would just summarize that the smart grid is critical to achieving those 4 E's: the economic competitiveness and energy independence, empowerment of the consumer, and the environmental sustainability. I would say that we should anticipate, especially with the empowerment of the consumer. I'm anticipating that the world's going to change very much like we saw in the aftermath of deregulation of the telcos. One time we all had basically the same phone, the same plan. In the future, I see a real segmentation of society where each of us are going to pick what's the right plan for us. There's going to be multiple tariffs. We're a long ways from that. We have a long ways to go. But all of that is going to be necessary to get a full deployment and utilization of the smart grid. And with that and the powering of the energy choices, we're going to see an optimization of energy, renewable energy. And last week, Secretary Chu was at this grid week. He was a keynote speaker there, and he made note to one of the challenges, because there's very, very aggressive renewable standards being set here about the integration of renewables and how much renewables we're going to have. And he seemed to tacitly acknowledge, one of the challenges is this transmission again. And I was at an event in Nevada a couple weeks ago and with developers there, and they were saying the same thing. They had no problem finding the sites and where they were going to put their projects, but they were really struggling with, just like Pickens again was struggling with, how do you get the power to market? Because there's still this issue about are we going to build more transmission? I mean, building transmission is controversial as well. And one of the things I took away from this discussion last week was we're going to see, I think one of the real big increases we're going to see is in distributed renewables. Because if transmission is an issue, centralized renewables have certain limitations, and there seems to be this. What I'm hearing now is that even though we're in single digits today on renewables, we may get to 20% renewables on centralized renewables. But there's going to become a physical limitation to transmission unless we're going to build more transmission. So there's room for growth, but it's not unended, which really then begs the question, if transmission becomes a challenge, I would expect, very much similar to what you just saw with the net zero home, we're going to see a real mushrooming of decentralized renewables. We're going to see more of us be generating at home and locally, and we're going to see more of that. So that's going to be a real growth area. And I think all of this is going to help us, again, be more productive, efficient. It's going to reduce CO2 emissions, and it's also going to help us integrate those plug-in electric vehicles. Thank you.